In this video, we're going to learn how to draw the Lewis structure of our molecule here. Some people call it Lewis dot, some people call it dot and cross, but whatever it is, we're drawing the structure. So the first step that we have to do is we draw the skeleton of this molecule. We know there's a carbon, and the carbon is flanked by two oxygens. So we draw the skeleton. There's our skeleton. It's easy to know which one is in the center. In some cases, they actually underline the one that's in the center like that, but IB doesn't usually do that. And the structures that they give you, or the molecules they give you to draw, are easy to determine which one should be in the center. Most of the time, it's the one that is 1 when the others are more than 1. So in this case, there's only one C and 2 O's. Okay, here's our skeleton structure. Now, our job is to make everybody happy, and everybody means all the atoms here. We should make them happy. If we look at the oxygen, it has 2 electrons, the ones that are shared between C and O. So if I put 3 lone pairs around oxygen, now the oxygen is happy, and I do the same thing on the other side to make the other oxygen happy. Our carbon is still not happy because it only has 4 electrons, the ones that are shared between each of the oxygens. So we put 2 lone pairs on carbon. Now carbon is happy. Okay, now we move on to the second step here, and we have to use the periodic table to determine the sum of valence electrons. C has 4 because it's in group 4 or 14, and then O has 6, and there's 2 of them, so total we're going to have 16 electrons. That's all that we have. This molecule or the species doesn't have a charge, so it's just the 16 electrons that we have to work with. Now we go back and we count how many we actually used. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we've used 20, but we only have 16. So this is a problem. If we have a case like that, it says here we have to make multiple bonds. And I'm just going to quickly draw the carbon dioxide as we have it above. So this is what we have above. Okay. Now, when we do the multiple bonds, what we are doing is we are going to remove 2 pairs of electrons, one from carbon and one from oxygen, and we're going to put a double bond. Okay, so it means we've used 2 electrons for the job of 4 electrons because everybody's still happy, but we've used less electrons. When we count here, we still have 18 electrons, sum of, that we've used. That means that we are still overusing. So we're still in debt, electron debt. So we can either put a triple bond between the C and the O so that we can use 4 electrons for the job of 2, or we can put a double bond on the other side. When you have a case like this, either one, I guess, is technically okay, but remember that nature likes things to be stable, and stable things are usually uniform. The more uniform something is, the more stable that it is. So if you put a triple bond and on the other side with a single bond, those things are not going to be very uniform. But if you put 2 double bonds, then there's uniformity and therefore stability. So that's what we do. We put a double bond on the other side. And now when we count, we have used 16 electrons. Okay, and this is our structure. This is what carbon dioxide looks like.